Hello friends, so let's continue with final exercise. In that we have given tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 8, 3 and tan inverse 1 by 8 equals to pi by 4 we have to prove. Okay, now let's say that there are 4 terms here we have, so let us go with any 2 terms together, right? I can take first 2 terms together and I can take the last 2 terms together, or you can take any combination of 2 terms together, right? So first of all, it's 1 by 5 plus 1 by 7 upon 1 minus 5 dot 1 by 7. Similarly, the same equation if I apply in the last 2 terms, so I will get 1 by 3 into 1 by 8. So it's tan inverse, it's 12 by 34 plus tan inverse 11 by 23. So tan inverse 6 by 17 plus tan inverse 11 by 23. So let us apply the same equation between these 2 terms also. 6 by 17, 11 by 23, 6 by 17, 11 by 23. So when you multiply, so 23 into 6 is 138, 11 17 that is 187, 17 into 23 that is 391 minus 61. So it's tan inverse of 325 by 325 and tan inverse 1 equals to pi by 4. Right? So you can take any combination of 2 terms together. Okay. Next question. Number 9. Now just check number 9, number 10, number 11. Right? Are very important. 9, 10 and 11. These 3 equations are very important. So number 9, in this we have to prove tan inverse root x equals half cos inverse 1 minus x by 1 plus x with the given condition x belongs to 0 to 1. Okay. Now as we discussed already, if you remember, that whatever we want to prove, that is already given in the question also. So just check that here tan inverse root x equals to, you want to prove 1 by 2 cos inverse 1 minus x by 1 plus cos 1 plus x. But here we're not going to take LHS and then we'll prove RHS. We'll first take RHS. Half cos inverse 1 minus x by 1 plus x, and in this I will take x equals tan square theta, because what I want to prove, I want to prove theta equals to tan inverse root x. I want to prove this. That's why I am taking this term as a substitute. Okay. So now if I put in the values of our RHS, half cos inverse x as 1 minus tan square theta upon 1 plus tan square theta. Okay. Now we know that 1 minus tan square theta by 1 plus tan square theta is an equation of cos 2 theta. Okay. Now according to the condition, if we have 0 less or equals to x less or equals to 1, so if we take square root on both the sides, then also it will be in between 0 to 1 equally. Now let's put the values. So we know that root x as tan theta, 0 will be tan 0, less or equals to tan theta, less or equals to 1 has tan pi by 4 value. Now as we know that tan is increasing in all, so 0 less or equals to theta less or equals to pi by 4, and if I want to take 2 theta, so 0 less or equals to 2 theta less or equals to pi by 2. So now, right? So now we can remove inverse and function, because we know that 0 to pi by 2 is the subset of 0 to pi, right? So it will be half into 2 theta as it is theta, and as theta equals tan inverse root x, which is equals to LHS. Right? Just follow simple rule that if you have from inverse with a variable, then you have to take substitute. If we don't have any standard forms, then follow what we need in the proof. Right? Next question. Next question we have cot inverse 1 plus sin x plus 1 minus sin x upon 1 plus sin x upon become 1 minus sin x, and we have to prove this equals to x by 2 with the given condition 0 to pi by 2. Sorry, 0 to pi by 4. Very first thing, how different ways they can ask this question. The very first thing they can do, here just check, we have plus sign in the numerator and minus sign in the denominator. So very first thing, they can interchange the sign. First thing. Second, just check, 1 plus sin x is subtracted from 1 minus sin x, so they can interchange this two also. Third thing, the condition, the very most important point is the condition. They can change the condition. Here the given condition is 0 to pi by 4. Maybe they can ask based on pi by 4 to pi by 2. Right? Why I am telling this? Because as far as the previous Gujarat Board's old textbook, there was this sum. There was a sum, but this sum was asked in 3 different ways in the single textbook. In a textbook only, the sum was asked in 3 different ways. Right? So that's why it is very important. Now, as we already discussed that cot inverse with function, so no need to go with the substitute. So we'll have to try to convert this whole equation in form of either tan or cot. Okay. Now to convert this equation in form of tan or cot, we have 2 methods or 3 methods. First method, you can take with the conjugate. Yeah, right. You can take the conjugate of denominator, the first method. Second, make a perfect square individually, 1 plus sign and 1 minus sign. And third method that we're going to apply is just check that in LHS it's cot inverse. Okay, can I write down 1 plus sin x as cos pi by 2 minus x. Similar thing I can write down in this point also. 1 plus cos pi by 2 minus x and 1 minus cos pi by 2 minus x. Now we all know that 1 plus cos theta is 2 cos square theta by 2, right? So I can say it's root of 2 cos square. Now this pi by 2 minus x is our theta. So theta by 2 will be what? Pi by 4 minus x by 2. Similarly, 1 minus cos theta is 2 sin square theta by 2. Similarly, 1 plus cos theta is again 2 cos square theta by 2. And 1 minus cos theta is again 2 sin square theta by 2. Hope you understand these two equations. 1 plus cos theta. 1 plus cos theta is what? 2 cos square theta by 2. Okay? And 1 minus cos theta is 2 sin square theta by 2. Now, 2 and 2 cancel from all. And if we remove from square root and square, so we have to put modulus, right? But I am not going to put modulus. I am telling you the reason. And I will directly write down cos pi by 4 minus x by 2 plus sin pi by 4 minus x by 2 upon cos pi by 4 minus x by 2 minus sin pi by 4 minus x by 2. I will directly write the, I have already written the term directly without putting the modulus. Because the reason is we already have 0 less x less pi by 4. If you want pi by x by 2, then it will be from 0 to pi by 8. And now if I multiply with minus, so minus pi by 8 less minus x by 2 less 0. And if you add pi by 4, so pi by 4 minus pi by 8, which is plus pi by 8 less than pi by 4 minus x by 2 less than pi by 4. So you just check that pi by 8 to pi by 4 represents the first quadrant, and in first quadrant all cos and both cos and sin is positive. Hope you understand this point, right? That's why this angle belongs to positive first quadrant, hence cos and sin will give you positive answer. Okay, now let us divide with cos, because as we want to obtain the equation of tan, we need 1 minus compulsory. So I need to divide with cos. So here I will get 1 plus tan pi by 4 minus x by 2 upon 1 minus 10 pi by 4 minus x by 2. Now instead of 1 I can say it's 10 pi by 4 plus 10 pi by 4 minus x by 2. Okay, pi by 4 minus x by 2, and 1 minus 10 pi by 4 into 10 pi by 4 minus x by 2. Okay, so this will become an equation of tan alpha plus beta, hence it is cot inverse of 10 pi by 2 minus x by 2, and 10 pi by 2 minus x by 2 is what? 10 pi by 2 minus x by 2 is what? Cot x by 2. And as we already proved that cos x by 2 belongs to 0 to pi by 8, which belongs to first quadrant, so we can remove inverse n function, and hence answer is x by 2, which is equals to RHS. Right? So if they can change the condition, if the condition will be from pi by 4 to x pi by 2, then where we find some changes? We find some changes over here. That right now if it is in between pi by 0 to pi by 4, then this angle belongs to first quadrant. Maybe if they put this condition pi by 4 to pi by 2, then maybe this angle belongs to negative quadrant, that is second quadrant also. So you need to check for that condition, right? So be careful while solving this sum, that what kind of condition they have given to us. Okay. Next question. Okay, in the next question we have tan inverse root 1 minus x, 1 plus x minus 1 minus x upon 1 plus x plus 1 minus x, and we have to prove pi by 4 minus half cos inverse x, where minus 1 by root 2 less x less 1 or equals to 2. Now if you just check, we have inverse with the variable, so we must have to take some substitute. And what substitute we're going to take? We'll take cos inverse x as theta. Okay, you can take cos inverse x also, cos theta is also x, right? But let us convert in the required forms that we discussed for taking substitute. If you want to just check LHS, if I divide with root 1 plus x, so what I will get? I will get 1 minus x by 1 plus x, and 1 plus 1 minus x by 1 plus x. Now if you just check, the similar kind of form we already discussed for taking the substitutes, right? And for this kind of condition we have discussed that either you can take substitute as cos theta or you can take cos 2 theta, no matter with the substitute, right? Whatever substitute we are going to take, according to that condition will be changed, right? But the answer never changes. Okay, so if I take x as cos 2 theta, okay, so what will be the condition? So it's tan inverse 1 minus cos 2 theta upon 1 plus cos 2 theta, and 1 plus 1 minus cos 2 theta upon 1 plus cos 2 theta. Okay, now just check that tan inverse of 1 minus cos 2 theta, that is 2 sin square theta, and 1 plus cos 2 theta, that is 2 cos square theta, by 1 plus again here 2 sin square theta upon 2 cos square theta. Now 2 cancel, sin square by cos square, that is root of tan square, and root of tan square will be written as, we can write as tan theta. So it is 1 minus tan theta upon 1 plus tan theta. Now again, as you remove square root and square, we have to put modulus, right? But let us derive the condition that minus 1 by 2 less than or equals to theta, x, less than or equals to 1. So now let us put all these value in terms of cos. Okay, so we know that cos 3 pi by 4 minus 1 by root 2 will goes to cos 3 pi by 4 cos 2 theta and cos 0. Now 0 to 3 pi by 4 represents first and second quadrant, and in both the quadrant cos is decreasing. So if I remove the function, I have to change the inequality, and then if I want to take theta, so divide with 2, so we'll get 0 to 3 pi by 8. Now just check, 0 to 3 pi by 8 represents first quadrant, and in first quadrant tan is positive, that's why I have not put modulus, because it will give us positive answer. Hope you understand this point. Now again, here we can say it is tan pi by 4 minus tan theta upon 1 plus tan pi by 4 tan theta. So this will become an equation of tan inverse of tan pi by 4 minus theta. And now for the given condition, 0 less theta less or equals to 3 pi by 8 minus, if I multiply and if I add pi by 4, so pi by 4 minus 3 pi by 8, pi by 4 minus 3 pi by 8 will give us minus pi by 8 less or equals to pi by 4 minus theta less or equals to pi by 4. So now this case, minus pi by 8 to pi by 4 will represent fourth quadrant and first quadrant, which is the domain of tan, right, which is minus pi by 2 to pi by 2. So this interval is a subset of minus pi by 2 to pi by 2. So we can remove function in inverse as it is pi by 4 minus theta. And now what if I take consider from this? So it will be 2 theta will be cos inverse x, 2 theta will be cos inverse x, and then if I divide with 2, so my answer is pi by 4 minus half cos inverse x. This is what I wanted to prove. Okay, so very carefully you have to solve this sum, right? Then next question. Number 12, we have to prove 9 pi by 8 minus 9 by 4 sine inverse 1 by 3 equals to 9 by 4 sine inverse 2 root 2 by 3. This is we have to prove, right? So this is LHS and we have to prove RHS. So let's go with the LHS first. So in LHS we have 9 pi by 8 minus 9 by 4 sine inverse 1 by 3. So we can find something common from this two term. We can find 9 by 4 common. So let me keep 9 by 4 outside. So here we get pi by 2 minus sine inverse 1 by 3. As we know that pi by 2 minus sine inverse 1 by 3 can be written as cos inverse 1 by 3. Right? And what cos inverse 1 by 3 can be? So let cos inverse 1 by 3 equals to, if I take theta, so cos theta is 1 by 3. So sin theta will be 1 minus cos square theta. So 1 minus 1 by 9, as it is 8 by 9 equals to 2 root 2 by 3. So I can represent LHS equals 9 by 4, and cos inverse 1 by 3 can be written as sine inverse 2 root 2 by 3 equals theta from this, right? So I can represent sine inverse 2 root 2 by 3. Simple sum, right? Next, number 13 is also important. We have given one equation. 2 cos inverse x equals tan inverse 2 cosec x, and we have to find out value of x from this equation. Value of x, that means we have to solve this equation, right? So let us apply the equation that it's 2 tan inverse theta. 2 tan inverse theta can be represented as tan inverse of 2 theta upon 1 minus theta square according to the equation, right? And on right hand side we can consider cosec x as sin x. Now as we can remove tan inverse from both the sides, as we can take this tan inverse on the opposite side. So tan of tan inverse function inverse cancel, right? So it will be 2 cos x by sin square x equals 2 upon sin x. So 2 will be cancelled from both the sides. Cos upon sin square minus 1 by sin x equals to 0. Very important point that whenever we have to find a solution based question, do not cancel variables from both the sides, right? So if someone say that let us cancel out this sin x from both the sides, so in the very first case don't do this, okay? First take the variable on the opposite side, find some factor. If you get that means cos x minus sin x upon sin square x equals 0. Now from this we can easily say that sin square x will never equal 0. In the denominator it is there. Okay, so I can consider this equals as cos x minus sin x equals 0. hence cos x equals sin x, hence tan x equals 1, and according to the domain we have discussed between minus pi by 4 to minus pi by 2 pi by 2, tan x is equals to tan pi by 4 implies x equals to pi by 4 is your answer. You can write down this in terms of generalized answer also, which you already studied in your 11th science if you remember. You can write down this as k pi plus pi by 4. Right? K pi plus pi by 4. But as far as the domain we restricted, minus pi by 2 to pi by 2. So in that domain, you can get only one answer, which is pi by 4. Okay?